So another area of game theory is called repeated games. And one really useful tool with Python for this is the Axelrod library. Now to install the Axelrod library again, just like we did for NashPy, we'll do pip install Axelrod. And there we go. And what the Axelrod library is really for is to reproduce, well, to study the prisoner's dilemma. It's called Axelrod because it's building on some work that was done in the 1980s. And let's see how that works. And so one of the conventions is to import Axelrod as Axel, just to save a bit of space. And this now has a lot of things. So for example, it has these strategies like tit for tats, tit for tat, which is a very famous one. So I'll call this player 1. And I create that player, and I'll say player 2 the Axelrod dot alternator. So this is just a player that alternates between cooperation and defection. For more background on the prisoner's dilemma, there'll be links in the description of the video for that. And then what we can do is we can create a match between these two players. And let's say they're going to play for 6 turns. And then if we do match.play, what comes out of there is how they cooperated against each other. So the first round they both cooperated, then the alternator defected, the tit for tat responded by defecting, and then they were caught in that loop. And we can do things like match.final score per turn. Oh, that's a method, so I need to call it. And so we see that tit for tat got 2.16 points per turn and alternator got 3 per turn. And we can do various other things, including creating a tournament by going Axelrod.tournament. And here we need to set a number of players. So what I'll actually do is create players equals S for S in Axel.demo strategies, just a small set of strategies. And again, I'll say turns equals 10 and repetitions equals 5. And then if we say results and tournament.play, that ran very quickly, but there are a huge number of strategies in the library, so sometimes it'll take longer. And then what I'm going to do is I'm just going to draw a plot. So if I do %matplotlib inline, and this is not a Python command, this is a Jupyter command to say I'm about to draw some things inside of a Jupyter notebook. And then if I do plot equals actual plot of results, so saying I want to start plotting these results, I'm going to do plot.boxplot. And that creates a ranked plot of the strategies and their utilities per turn. You see in this particular game, the defector and the grudger beat tit for tat and random. If I put that on, it'll only draw it the one time. And as I said, there's a huge amount of strategies in the Axelrod library. If we take a look at the version of the Axelrod library we're looking at here is 3.81, and if we do length of Axel.strategies, we see there are 204 strategies in there, but some of these strategies can be parameterized, so there's even more. So the Axelrod library is a useful resource for studying the prisoner's dilemma.